So for part A, we need to find the derivative of the function f of x. F of x is minus x minus h whole squared plus 2k. Whenever you need to find the derivative of a function, all of your constants become 0. So in this question, you're basically asked to find the derivative of minus x minus h whole squared. The reason why 2k was cancelled was because it's a constant and it doesn't have the variable x, because that's what we're finding our derivative with reference to. Now we're going to be using the chain rule in this step. First, we're going to be finding the derivative of the whole bracket as one single term. That means we're going to move the 2 to the coefficient. So we're going to get minus 2 because of this minus sign. And then we're going to raise it to the power of 2 minus 1, which is 1, so we can leave it the way it is. Then, following chain rule, we're going to multiply this by the derivative of the inner function, and the derivative of x minus h is just 1, so we can multiply this by 1, and we're going to have minus 2 into x minus h. The graphs of f and g have a common tangent at x equals 3. Show that h equals e plus 6 over 2. If you have a common tangent, then that basically means that your derivative is equal. So when x equals 3, if your tangents are common, that means you have the same derivative. Since we've already found the derivative of the function f of x, which is minus 2x minus h, we can put that as our derivative of f of x. And then for g of x, we can find the derivative as d over dx of e power x minus 2. Now up here, we can see that g of x is e power x minus 2 plus k, where k is a constant. So we wouldn't need to consider k when we're finding the derivative. That way, when we find the derivative of e power x minus 2, we're again going to use chain rule. E power anything is the same thing as e power that value if you're finding its derivative. So this will remain as e power x minus 2. However, you're going to multiply this by 1 because that's the derivative of this inner function, which is x minus 2. So this is by using chain rule, we're going to get e power x minus 2. Since the derivatives are equal when x equals 3, because of this case where they have a common tangent, that will mean that minus 2 times x minus h is equal to e power x minus 2. Then what we're going to do is we're going to divide both sides by minus 2. That way we're going to get rid of the coefficient on x minus h, and then we're going to have e power x minus 2 over minus 2. And since we have a value for x, which is 3, as we have been stated over here, we can use this value to get 3 minus h equals e power 3 minus 2 over minus 2, as we had x over here and x over here. That's why minus h becomes minus e over 2 minus 3, and if you multiply everything by the negative sign, you get h equals e plus 6 over 2, which is the case that you had to show. The last part asks us to show that k equals e plus e squared over 4. Since we know that at x equals 3, the derivatives are the same, that would also mean that the term, or rather the functional term, is also the same. So f of x would be equal to g of x at x equals 3. What that means is if we go up here and we look at what f of x is and what g of x is and replace 3 with x, we can find out the value because they both will be the same in terms of their magnitude. So that will mean that when we replace x, we're going to get minus 3 minus e plus 6 over 2. And the reason why we're doing that is because we're going to be putting x over here. So over here we'll have minus 3 minus h, which is the value we had just found as e plus 6 over 2 squared, plus 2k. Since we don't know what k is, we can leave it. And g of x would be e power 3 minus 2 plus k, as we can see over here. Since we know 3 minus 2 is 1, this will be e power 1 plus k, so we can leave that as e plus k for the value of g of x. Then what I'm going to do is I'm going to take this k to the left-hand side of the equation, and I'm going to take this whole term to the right-hand side of the equation. That way I'll get k equals e plus this entire thing, which is plus 6 minus e minus 6 over 2, because I multiplied this by 2 and divided the entire thing by 2 to get your common denominator. Now I can multiply this together. What I'm going to do next is simply 6 minus 6, because those two terms are the same. I'll get minus e over 2 whole squared. And this way, I'll get k equals e plus e squared over 4, as we had been asked to show in the question.